Hello, and welcome to Introduction to Variables. What are variables? Variables are used in different ways in math, but we rarely talk about how a variable is being used in each situation. Continue to learn more about the distinct uses of variables. One way we use variables is to represent an unknown. Probably the most familiar way to use a variable is to represent a single unknown value in an equation. In equations, there can only be one value for the variable to make the equation true. In the following examples, there can only be one value for x, that when you add 6 to it equals 20. There's only one value for x, that when you do 10 minus that number, you get 1. And when you find half of 20, there's only one value that you'll find. A second way we can use variables is in an expression. During this topic, we'll learn more about expressions. When a variable is in an expression, we can be told to evaluate the expression when the variable is a certain number. Look at the following example. We're told to evaluate the expression when x is equal to 5. The expression is x plus 6. So we replace the variable with the given value and evaluate. We replace the x with the number 5. Evaluate the expression. 5 plus 6 is 11. A third way we can use variables is to represent many numbers at the same time. A variable in an inequality can have many values at once. For example, x plus 1 is greater than 6. X could be 6, 7, 8, 9, 10, and on. There's an infinite number of values that x could have. Variables are also used in formulas. In a formula, variables represent specific quantities like length, width, area, distance, time, etc. In the first example, the capital A represents area. Area is equal to the base multiplied by the height. And that's how you find the area of a rectangle or a parallelogram. The capital V stands for volume. Volume of a rectangular prism is found by multiplying the length times the width and then multiplying that by the height. Distance is equal to the rate times time. So to find out how far you'll travel in 3 hours, you take your average speed, which is the rate, and multiply it by the number of hours you're traveling, and that will tell you the distance or the number of miles you will be traveling. A final way that we can use variables is within a rule or a property. Rules or properties are equations that are always true. Always. We often use variables at the beginning of the alphabet when writing properties. For example, any number plus 0 is equivalent to that number. We write that as a plus 0 equals a. We know that addition is commutative, and that means that we can add numbers forwards and backwards and not change our answer. So we know that 5 plus 10 is the same as 10 plus 5. We know that when we add opposites together, they equal 0. So negative 7 plus 7 is equal to 0, and that's always true. We recently learned that a to the 0 power is 1, and that's true for every value of a. So why do we use x as a variable? In this TED Talk, we'll learn more about why X is being used.
I have the answer to a question that we've all asked. The question is, why is it that the letter X represents the unknown? Now, I know we learned that in math class, but now it's everywhere in the culture. The X Prize, the X Files, Project X, TEDx. Where'd that come from? About 6 years ago, I decided that I would learn Arabic, which turns out to be a supremely logical language. To write a word or a phrase or a sentence in Arabic is like crafting an equation because every part is extremely precise and carries a lot of information. That's one of the reasons so much of what we've come to think of as Western science and mathematics and engineering was really worked out in the first few centuries of the Common Era by the Persians and the Arabs and the Turks. This includes the little system in Arabic called algebra, and algebra roughly translates to the system for reconciling disparate parts. Algebra finally came into English as algebra, one example among many. The Arabic texts containing this mathematical wisdom finally made their way to Europe, which is to say Spain, in the 11th and 12th century. And when they arrived, there was tremendous interest in translating this wisdom into a European language. But there were problems. One problem is there are some sounds in Arabic that just don't make it through a European voice box without lots of practice. Trust me on that one. Also, those very sounds tend not to be represented by the characters that are available in European languages. Here's one of the culprits. This is the letter sheen, and it makes the sound we think of as sh. Sh. It's also the very first letter of the word shay'un, which means something, just like the English word something, some undefined, unknown thing. Now, in Arabic, we can make this definite by adding the definite article al. So this is al-shay'un, the unknown thing. And this is a word that appears throughout early mathematics, such as this 10th century derivation of proofs. The problem for the medieval Spanish scholars who were tasked with translating this material is that the letter sheen and the word shay'un can't be rendered into Spanish because Spanish doesn't have that sh, that sh sound. So by convention, they created a rule in which they borrowed the ck sound, the k sound, from the classical Greek in the form of the letter chi. Later, when this material was translated into a common European language, which is to say Latin, they simply replaced the Greek chi with the Latin X. And once that happened, once this material was in Latin, it formed the basis for mathematics textbooks for almost 600 years. But now we have the answer to our question. Why is it that X is the unknown? X is the unknown because you can't say sh in Spanish. And I thought that was worth sharing.